Hello all, welcome to the time series analysis and forecasting lectures. So in this we'll see what is time series. So time series is data that is collected, recorded and observed over a time in sequential order. So it has some characteristic. For example, it should be in a chronological order. That means observations are in order of some time, right? Like for example, if you are collecting data date wise, day wise, that is okay. So all the data should be day wise, and if you are collecting data second wise, then it should be second wise, right? So it's not like in between different order of date is appearing in the data. That is how you'll not store the time series data. It should have some form of chronological order, that it is monthly, weekly, daily, something like that data is there. It should have a sequential dependency. So the order of data matters because previous values can influence or predict the future values, right? So whatever happened yesterday can affect today. For example, temperature yesterday was 30, then it's highly likely that today it's going to be around 30. Not going to be changed much, right? For example, even if it's changing weathers from winter to summers, it will not drastically do. It will slowly it will do. Now there could be some temporal components in the time series also. For example, there should be a trend. There could be a trend, upside, downside, no trend, something like that. Seasonality could be there in the data, that it's changing across season, like repeating pattern across some time period, exact time period, right? So something like that, repeating pattern at a fixed interval. If it is that's called season. Cycle is again like it's a repeating pattern, but there is no fixed interval. It can happen anytime. That kind of it's a cycle, and there could be some noise. This will be there, which will never be able to capture. Okay, so something like that should are the characteristic of a time series. Now, what requires in time series is like one thing you can do is you can find some insight about pattern and trends of the data. Past data you can take and find some insights, and you can use that to make prediction, or you can use that to decide what to do about a product in a company. For example, should we give a discount of this product? Should we do advertisement about this product? Should we cancel this, like will not go further with this product? So something like that, predictions or forecasting will be there. So something like that you can do about product if you have time series data. Okay. Now yeah, so time series. So what we can do is we'll cover in this what is classical decomposition. So we have a data, and it has this temporal components such as trend, seasonality and noise. So cyclicity is not, we can't capture that. But what we can capture is we can capture seasonality and noise and trend, that what is that, and we wanted to decompose that. So decomposition means we wanted to take out each component out of the series, and we wanted to analyze that only, right? The reason we wanted to do this is so that if we understand each component and what forms it to the time series, we can maybe predict better, right? So that is the idea behind it, that we want to do that. Now yes, so for this let's see what data we have. So we'll import this NumPy, Pandas and Matplotlib. So this is our data on airline passenger. So it's a data of monthly, how many passenger flew from A place to B in, let's say, 1949, then it goes up to some values, right? So there are 144 rows, and what you can do is you can plot the data, and you can see month wise the data is going something like this, right? So you can see it is increasing, it has a uptrend, right? So you can clearly see it is at least uptrend, it's going upwards, and there are some seasons on it. So the repeating pattern you can see here again, same thing is happening, right? It is magnifying, but it is same pattern which is happening here, right? So you can see that is seasonality, and some amount of noise will be there, which we are not able to capture in this in by trend or season, right? So what we can do is now let's say we know what is trend component in this, and what let's say we know season component also in this, right? Now what should we do? Should we add them to, so if each decomposition we have, should we add them to get the final time series, or should we multiply them, or is there any other way to do this also? So there are two ways to do it. One is additive way and another is multiplicative way. You can do it. I mean, additive way, when you should apply additive is when you can see the graph is very constant, like the peaks and the bottom are almost of same size, and it's going in a upward trend fashion. That is okay. So seasons are very you can say well balanced, right? It's not going it's not changing across time. So this kind of model, for this kind of charts, you can apply additive thing. But if you have this kind of chart which is very small in the early days, and then later on it goes very high, right? So here you can say it's exponentially increasing time series. Then in this cases we should do multiplication of trend and season, right? So it's not just the season is growing, but across that, along with that, the trend is also going, right? So the here trend is almost linear, but here it's exponential. So if this two other, then that's what. So what I mean by that is that if I wanted to predict my y, then that prediction will come from or if I say what is my time series data, that is going to be trend component plus season component plus some residuals, right? So the residuals is noise I was talking about. Then another could be a multiplicative way where you multiply time with season and you multiply residuals on top of that. So this is another way a time series could have formed, right? So this is our hypothesis, that we are kind of assuming that this way a time was formed, right? Now are only these two ways or more ways possible? Like it is possible, like maybe you take multiply of this and t and s, and you add r on that. So there's something like some variations are also there, but these are the most basic way to say that this is an additive series, or it's a multiplicative model, right? So this is like a model. Which kind of model you wanted to build, additive model or multiplicative model, you can kind of decide with the graph. Now we'll see much like how we can do with the graph, but let's see what we have here. So let's say if I have Reliance data I have downloaded from 2020 1st January 2023 to 1st October 2025. Now what I have is yeah, so this is how my close looks like. So close of the data, if you plot, you will get like this. Now here it's very hard visually to visually say that is it a uptrend, is it, what kind of seasons are there, right? So like I can't say anywhere seasons are noticeable or not. So maybe here in some portion you can say a little bit of seasons are there, but then it goes away, right? So this each component are there, but we can't able to figure it out. It will be there. So season some trend is there, like let's say uptrend here, right, and then downtrend, then uptrend, then some no trend, then downtrend, right? So this all will be there, but it's very hard to notice this. So what we can do is we will not rely on our intuition that what it is. Like what we can do is there is a model in statmodels.t, say seasonal. From seasonal you have to import seasonal decompose. So what this will do is if I use seasonal decompose and give my data, right? So whatever data is, I have to give that column only. I don't have to give the whole all the columns, right? Multiple columns are there. I am just looking for one column here. And what kind of model you have to mention here, like multiplicative, additive, or whatever, right? And you have to set some period. So this period means like when and like in what period it is repeating or something like that, right? So you have to maybe experiment with this how 10 come up, but but it's not a short sort. It's like a hyperparameter. You have to change and you have to see. Okay. Now, if you run this, then it will give you this. I have stored it in SD. Now, SD will give you three things. One is trend, another seasonal, and another is residual. Right. So this is how you have to write for residual. So this will give you three things. Now, maybe we can add them, we can multiply them, and we get a prediction of it, right? So estimation we can get from that. So let's say if I plot all these three things, so what I'm plotting is I'm plotting my passengers, then I'm plotting trend, and then I'm plotting seasonals that I got here, and then I'm plotting residuals, right? So if you plot them, you can see this looks like this, the chart, and so this is my original data. Now it is the same thing which we saw earlier. It was just the height got reduced, right? So that's why it got squished, but it's the same thing. Now you can see the trend is clearly, we can see it is very clear that it is uptrend, and the season components are also, we can see it's a very clear indication what are season components in this. Okay. And some residual noise is there which we couldn't able to capture, so the noise is there, and that's how you can do decomposition of any time series. So this is just a classical decomposition where we use multiplicative. Here you can use additive also if you feel that it's an additive model, that also you can do. Now yeah, so same thing done for the Reliance data, so stock data close, and you can do so if this is what I wanted to plot, you can see the residual, sorry, this is the trend component. You can see it's a little bit more cleaner to analyze how trend is going on, and then here the seasonal components are there which are very hard to pick up from the initial original data, and some residual noise which will always be there. Okay. Now what are some issues with it, or what we can say is it assumes fixed seasonal patterns. So you can see the seasonal patterns are fixed, that's what it assumes is, and easily influenced by outliers. So if there is outlier residual, then you can see, even though if it is that, it is still going to give this kind of chart, right? We don't need that. We might need to have it different chart if there are different I mean the chart should adjust accordingly based on the how actually season is going on, right? So fixed season is not a good idea. We need a little bit of changes if seasons are also changing. Now handle both additive and multiplicative models. It can handle both of them. So this I'm talking about the STL or seasonal decompose I am talking about, that it will handle both additive and multiplicative, but it is preferred for multiplicative models. So if you feel this is a multiplicative model, you can implement this. Now what we can do is, so let's say I'm putting matplotlib, but let's say if I say trend plus season is my estimations, then you can plot that, and you can see the red is the estimation and true values are the other in blue colors, right? You can see almost it is fitting there. Now it is going somewhere here and there little bit, but it is a good estimation we were able to make out of the data, right? So yet we haven't done any future or forecasting of this, but we'll do that soon, right? So we'll learn some models and we'll do the forecasting in that. Okay. So this is what squared error is coming out for this. Now if you take maybe another data, you will get lesser squared data. That is that's better. So we need less and less value of this. Okay. Yeah, so that's all there for time series decomposition using classical method. Now in next class, what we'll do is we'll see how to do STL decomposition. That is called Lewis estimated scatter plot smoothing. Okay, thank you.